Was Mars ever habitable by living creatures? That's a question NASA's Curiosity rover has been trying to determine for years. And recently, according to new evidence gathered in the Gale crater, where the rover has been exploring, the red planet may have been able to harbor life billions of years ago.
Hey everybody, welcome to Studio 64. My name's David and I've been searching the interzones for some more science, space and tech news to share with you. And I came across this over at Science Alert. This should be very interesting. Curiosity detects habitable Earth-like past on Mars, but how did oxygen get there? That should be very interesting. Interesting indeed. Rocks scrutinized by the Curiosity rover in an ancient, long-dried lake bed on Mars have revealed conditions likely to have been habitable billions of years ago. Now there, in rocks on the Gale crater, Curiosity found a surprising amount of manganese oxide, a mineral that is commonly found in lakes on Earth due to the highly oxidating conditions therein, which causes manganese crystals to form in the presence of oxygen. This is interesting. I'm not a scientist myself, as I always say. I just love all this stuff and, this exogeology, if you like. If there's any planetary scientists out there, please feel free to comment because, I'd love to hear from you. This is great. I just love sharing science and space and tech news. I think it's fantastic. A student of all sciences, and I love learning about it. As usual, I'll leave a link to the main article down below the video so you can pop in and check out these embedded links if you want to go for a bit of a deeper dive, beyond the main article. It makes for a very interesting read, believe me. Its discovery on Mars in such great quantities suggests that perhaps similar conditions persisted in the Gale crater when it was filled with water in eons past. Now on Earth, these types of deposits happen all the time because of the high oxygen in our atmosphere produced by photosynthetic life and from microbes that help catalyze those manganese oxidization reactions, explains geochemist Patrick Gazda of Los Alamos National Laboratory. Yes, that Los Alamos National Laboratory is really incredible. I did a video documentary on it years and years ago. It's an amazing place. Would it be safe to say it's the American equivalent of the British Bletchley Park or something like that? I think, is it Bletchley Park in the UK? Yeah, it's incredible. Some of the stuff they come out with is fascinating. On Mars, we don't have evidence of life, and the mechanism to produce oxygen in Mars's ancient atmosphere is unclear. So how the manganese oxide was formed and concentrated here is really puzzling. These findings point to larger processes occurring in the Martian atmosphere or surface water and show that more work needs to be done to understand oxidization on Mars. Now, manganese oxide is common and abundant here on Earth, and intricately involved in biological processes to boot. It is essential, it is essential mineral for several human biological processes, but pretty much all life on Earth requires manganese for some reason or another. And there's a short little video here, and I think we should check it out. Curiosity rover discovers signs that Mars was once habitable, and we'll check out this video and then we'll carry on the conversation when we come out the other side.
Was Mars ever habitable by living creatures? That's a question NASA's Curiosity rover has been trying to determine for years. And recently, according to new evidence gathered in the Gale crater, where the rover has been exploring, the red planet may have been able to harbor life billions of years ago. The rover found manganese oxide, which is a mineral that is often found in lakes on our planet. On Earth, it occurs during oxidation, meaning oxygen must be present when the crystals form. If the same process once happened on Mars, it could mean that the planet once had enough oxygen for life to survive. Geochemist at Los Alamos National Laboratory, Patrick Gazda, had this to say about it. On Earth, these types of deposits happen all the time because of the high oxygen in our atmosphere, produced by photosynthetic life, and from microbes that help catalyze these manganese oxidation reactions. However, he also says that because we don't yet have evidence of life on Mars, or how oxygen would have been produced there, this discovery raises as many questions as it does answers. With planetary scientist Nina Lanza saying, the Gale Lake environment, as revealed by these ancient rocks, gives us a window into a habitable environment that looks surprisingly similar to places on Earth today.
All right, well, that was intensely interesting. I love that sort of stuff. That's great. Just amazes me. I just love science. Get all excited down in my nerdy nether regions. But then again, my personal life is no concern of yours. There are even bacteria that rely on the oxidation states of manganese for energy, and their presence can accelerate the oxidation process. There isn't a lot of oxygen floating around on Mars now, and we've certainly found no evidence of living bacteria. So exactly how the manganese came to be hanging around there in sedimentary rocks on shoreline deposits in quantities comparable to an Earth-like environment isn't clear. I wonder what happened. Was it a massive climate type event, or was it just was it like a gigantic meteorite hit Mars? I mean, there's one theory floating around, and again, people laugh at it, but was Mars once had a highly advanced civilization on it, and they blew each other up with nuclear war, with nuclear weapons? Sounds like a weird theory, but you never know. Anything's possible. I mean, we only know from our own human experience what we have in our heads. We think we're the oldest civilization. We think we're the oldest this and the oldest that. There could have been civilizations on other worlds before us. There could have been a civilization on this world that was greater than, modern history, so to speak. We don't know, There's hints of it, but we don't know. Be interesting to find out what happened to Mars one day, why it's like it is today. Gazda and his colleagues made a careful study of the manganese as analysed by Curiosity's ChemCam, which uses a laser to vaporise minerals and then analyses the light to determine their composition. Then the researchers explored different mechanisms for the precipitation of manganese in the Gale Crater Lake, precipitation from lake water or from groundwater through porous sands. Now, all mechanisms require the presence of highly oxidizing conditions, and after running through these options, the researchers concluded that the most likely scenario would have been the precipitation of manganese oxides along a lakeshore in the presence of an oxygen-rich atmosphere. Now, this is further evidence, they say, of a long-lived and habitable lake environment in the ancient Gale crater on Mars, since it can take thousands of years for manganese oxide to form, depending on oxygen levels. I wonder if that... I've got a weird brain. I'm wondering if that Gale crater with the lake in it, I wonder if there was any intelligent life around at that time, and they had a pop culture like ours, and they had they had horror movies filmed on it where teenagers go to summer camp on that lake, and they were attacked by somebody like Jason Voorhees or some horror movie teen slasher or something. Yeah, God, I've got a weird brain, Martian mayhem. God, you're a weirdo, David. Where that oxygen came from is another question that remains unanswered, although it's possible that meteorite impacts early in Mars's history could have released oxygen from surface ice deposits. Nevertheless, the findings offer a tantalizing prospect for looking for traces of ancient life on the red planet. Microbe-mediated oxygen may have left biosignatures and organics in the manganese-bearing rocks. Perseverance, which is currently exploring a dried-up delta environment, could look for these in its travels, the researchers say. Now, the Gale Lake environment, as revealed by these ancient rocks, gives us a window into a habitable environment that looks surprisingly similar to places on Earth today, says planetary scientist Nina Launza of the Los Alamos National Laboratory. Now, manganese minerals are common in the shallow oxic waters found on lake shores on Earth, and it's remarkable to find such recognisable features on ancient Mars. The team's research has been published in the Journal of Geophysical Research, Planets, and as I say, link to the main article below the video. You can pop in and check out these embedded links, go for a bit of a deeper dive. It's quite fascinating. Yeah, I love that. That's awesome. I mean, again, not a scientist, but I just have this rather fertile imagination, and I just wonder if there is life on Mars now, but they're hiding from us. And every time we send a probe there, they hide. They duck. Oh God, here they come again. They duck behind a rock or something. That'd be fascinating. Again, there's a link down the below this video to. Let's just say if that scenario was a possibility of what could happen. Could be entertaining. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video because I'd love to hear what you think. All right, take care, and as I always say, if you can't be good at it. And as I also always say,
A most fascinating thing happened.